So earlier when we were talking about control plan, where we were talking about the length of that wooden chair, each of these legs were measured by the operator and these were recorded on a control chart which was X bar R chart. Now what's this control chart? Control chart is a chart which studies the process behavior over time. So let's say this operator is measuring legs of the chair, keeps on recording that. Control chart can help you in finding out if there is any trend, if there is any drift. For example, the length slowly starts getting more and more and more because of some adjustment in the machine, or length gets shorter. So all these trends can be caught using this chart, which is control chart. There are number of control charts. We are not going into the details of that. But right now we are just looking at one simple example of a control chart and just to show you how a control chart looks like. So here in this control chart, you put all these measurements over time. So let's say the first piece, the second piece, third piece, you keep on recording that dimension, measurement, whatever you are measuring, you keep on recording that, and that can help you in showing the trend. If you look at this top chart, here you can see that there is a trend here. Let's say it shows some sort of a trend which shows that with time this particular dimension is changing. That's how control chart can help you. In addition to that, what control chart does is control chart puts upper and lower control limits as well. So from the data which you collect, control chart will find out which of this variation is the normal variation or the variation because of common cause, and which of this variation is because of special cause. So anything which falls within these two limits, upper control limit or lower control limit, so these are the limits. Anything between these two lines is considered to be acceptable or considered to be within control, because this is something which is because of common cause. Anything has fluctuation, so it's considered that anything between these two lines is that sort of a fluctuation which happens everywhere. But then anything which goes out of this line is considered to be because of special cause. So if you look at one point here, which is the red dot, this red dot shows that something has happened here and that needs to be investigated. So control chart can help you in finding out that at what time you need to take action and at what time you need to ignore the fluctuation. You ignore the fluctuation if things are within this control limits, and you take action when one or more of these points go outside this limit, which is, let's say, here number 3. This is an example of X bar R chart where you plot two charts side by side. X bar is the mean chart, R is the range. We did study about mean and range when we looked at basic statistics very early in this course. So based on that only this chart is drawn. We are not going into the details of how to draw that, how to calculate the upper and lower control limits. All these things will be discussed in green belt course. But right now the scope of this yellow belt is just to have a good understanding that there is something called control charts which has mean, upper control limit, lower control limit. And here is one example which is X bar R chart, which is used for continuous data. So this completes our discussion on control chart, which you can use as an important tool in the control phase of DMAC process.